In these problems, we are simplifying some more radical expressions, and this time they have a couple of different variables and a number part. So we'll just take this one piece at a time. Let's actually start with the number part in this one, the square root of 20. What would that simplify to? Well, let's see. 20 is 4 times 5, and that's a good way to factor it because 4 is a perfect square. So I can take the square root of that, and that would give me a 2. So this is 2 times the square root of 5. Now, let's take the x to the eighth part. You may remember that when you take the square root of an even exponent, all you have to do is just divide that exponent by 2. So that's going to be x to the fourth. So if I want to rewrite this, the x to the fourth would go on the outside here. So I'm going to have 2 times x to the fourth, and then I've got my square root of 5. And then all we have left to deal with is this y. And this is maybe a little bit different from what you've seen before. We have an odd exponent here. Well, the way to think about this is to rewrite that y to the third as y to the second times y, or y to the first. That y to the second you can take the square root of. That's just y. So that comes outside here. And this plain old y, we can't do anything else with. It's not an even exponent, it's just a y. So that stays underneath the square root symbol. So in the end, we have 2x to the fourth y on the outside and 5y left on the inside. You know, another way to think about this would just be to take this whole expression on the inside, this 20x to the eighth, y to the third, and say to yourself, I want to factor out all the things that are perfect squares. So if I were going to do that, out of the 20, I could factor out a 4, and x to the eighth is a perfect square, so I could factor that out. And out of y to the third, I could factor out a y to the second. What that leaves is the 5 from the 20, nothing from the x, and just a y. And now you can take the square root of that part and leave this part inside, and you'd end up exactly with what we got here. Let's try one more of these just for practice. I'm going to go ahead and use that factoring method. So I've got 12 t to the seventh, w to the sixth. So let's go ahead and factor. Are there any perfect squares we can factor out of 12? Well, 12 is 3 times 4, and 4 is a perfect square. So that'd give me a 4, and it would leave a 3. T to the seventh, I can factor out a t to the sixth, because any even power here is going to be a perfect square. That just leaves a t behind. And then w to the sixth is a perfect square, so we'll include that in our factor. So that leaves this as our perfect square factor, and this is what's left over. So now we go ahead and take the square root of that. So the square root of 4 is 2. The square root of t to the sixth is t to the third. Remember, we just divide by 2. The square root of w to the sixth is w to the third. And what gets left behind that we can't do anything else with is just the 3t. So we put that under the radical sign. So that is a little bit more work with simplifying radical expressions.